In this video, we are going to be looking at the chain rule. Now, the chain rule is represented in the formula dy dx equal to dy du times du dx. The chain rule is represented in this formula. Now we are going to be looking at examples in this video that we are going to be applying this formula on to get our answers. Number 1, you are given y to be equal to nx plus n all raised to m. Now let u to be equal to the inner function here, which is nx plus n. Then if u is equal to this, then that means y will now reduce to u raised to m. Now we take the differentiation of dy with respect to u. Dy du is going to be equal to mu raised to m minus 1. Now we also take the derivative of u with respect to x. That means the u over dx will be equal to n in this case. So we are going to multiply du dx and dy du together. That is as the case in our formula. Then dy dx is going to be equal to dy du here is mu raised to m minus 1 times du dx here is n. So this is equal to mn u raised to m minus 1. Now we are going to substitute back our value of u, which is nx plus n. That means mn into nx plus n will be all raised to m minus 1. So that also means that factorizing n outside here, we are going to have, let me change this in. Factorizing n outside, we are going to have mn squared into x plus 1 all raised to m minus 1. And this is our dy dx. So now let's move to the next example. Now let's look at our second example, which is y is equal to sine nx. Now when we look at this carefully, we discover that our inner function here is nx. Now let u to be equal to nx. Now that means this will reduce to y equal to sine u. Then it means dy du will be equal to cos u. dy du it will be equal to cos u. Now du here over dx will be equal to n. So now from our formula dy dx, which is equal to dy du times du dx, let's now substitute our values. We'll substitute our values. Then dy dx will be equal to dy du is equal to cos u here times du dx is equal to n here. So this will be equal to cos n. This will be equal to n cos u, and we know our this will be n cos. We know our u to be equal to is equal to what? Nx. Our u is equal to nx. Then that means we are going to have nx here. So dy dx is equal to n cos nx. So this is our dy dx. Now we're moving to the third example. In our third example, we have y to be equal to ln sine 3x. Y is equal to ln sine 3x. So here we are going to let u will be equal to sine 3x. Now that means y will reduce to the u. Then dy du is going to be equal to 1 over u. if you differentiate the lane of u, we are going to have 1 over u. Now that means the u dx is going to be equal to 3 cos 3x. Going to give 3 cos 3x. Look at this 3 here. This is similar to the number 2 that we solved. The example 2 we just solved. So when you differentiate this, so when you look at this now, you discover that it's similar to what we solved in example 2, where you have n sine nx. When you have sine nx rather, then it's similar to sine 3x here. So now let's go further into this solution. So we have the du dx to be this, and we have dy dx du to be this. So we are going to multiply these two now using our formula. We are going to multiply these two using our formula dy dx to be equal to dy du times du dx. So if you solve that dy dx, if you substitute this value now, you are going to have dy du to be equal to 1 over u times du dx to be equal to 3 cos 3x. So this is going to be equal to 3 cos 3x divided by u. Now let's substitute back our value of u. This is 3 cos 3x, and we had our value of u to be equal to what? U to be equal to sine 3x. So you discover that we have cos 3x divided by sine 3x. So this will reduce to dy dx will be equal to 3 cos 3x. This is dy dx, because in trigonometry identity, cos x over sine s is equal to cos x. So this is what you have. Please like this video, subscribe to this YouTube channel, and hit the notification bell to get updated each time we upload a video. Thank you.